Hello, welcome back to our channel. Today we're going to be talking about trigonometric graphs, how to sketch sine, cosine, and tangent graphs, and how to find solutions or values for x within 0 to 360 degrees. You need a calculator for this lesson. This particular graphs could be explained using unit circle, but most students are conversant with x and y coordinate for plotting graphs, so I want to adopt this approach of using table of values. Now, what I want you to understand is that in sketching trigonometric graphs, the x coordinate are angles from 0 to 360. That's for a start. We're going to only consider 0 to 360. Now, the angle, we've selected specific angles: 0, 90, 180, 270, and 360. You can do 0, 30, 60, 90, 120, and so on, go on in 30s. But for this lesson, I've chosen these 5 points. So find sine 0, sine 90, and so on, and you see what you have. You'll have these values, and if you plot them as normal coordinate point, and you join with a smooth curve, this is what you have. So this is what we call a typical sine graph. Typical sine graph within 0 to 360. This is what it looks like. And you need to be very particular about the coordinate points. These are the coordinate points that you need to be very particular about, because in an exam they could do a sketch and they will ask you to find out the coordinate of this point. You should be able to know by heart. Coordinate of this point you should be able to know by heart. Also, we call something the amplitude. The amplitude is the height of the wave. That's like a wave. The height of the wave, and it's 1 in this particular case. The amplitude is the height of the wave. And the values of y, as you can see, ranges from 1 to -1. The highest number is 1. The lowest number is -1. The reason is that y sine x is the same as y equals 1 sine x. So y equals sine x is 1 sine x. That's what it means. That's why the values ranges from 1 to -1. We'll talk more of it when you go to transforming trig graphs. So this is what it looks like for sine graph within 360. One more feature is a period. Period is that how long will it take for a full cycle to complete? It takes 360 for a full sine graph to complete itself. So it continues every 360. You're going to have a sine graph. So if you continue, the next one will end at 720, and so on and so on. If you go to negative range, the same will happen. Negative 360, you're going to have another sine graph. So it means every 360, you're going to have a sine graph. So we are able to use this to predict the shape of the sine graph as you go beyond 360. The same for cosine. Work out with your calculator. You're going to have these numbers, and if you plot and sketch, this is the nature of a cosine graph. Also, the amplitude is 1, as you can see, because if you continue, you're going to have another 1. So amplitude is 1, the same as this one is 1, but we talk about absolute value. So even though it's -1, we still regard it as 1. It's absolute value that we look at, not the sign. Its absolute value is 1. And the important coordinate points are here as well. Then we say the values are between 1 and -1, because y cos x is the same as 1, y equals 1 cos x. Period is 360 also. Every 360 you have the shape of a cos graph. Every 360 and so on. It continues also in the negative section as well. So this is cos graph. Tangent graph looks like this. If you use a table of value, you see the same thing. You have that you cannot define tan of 90 to be undefined. So we have something called asymptotes. And asymptotes are negative 90, 90, 270, and so on. So every 180 degrees, you have a tangent graph. Every 180, you have a tangent graph. So we say the period is 180. It's not 360 like sine and cosine graph. So this is typically what tangent, cosine, and sine graph looks like. Now, you may be asked to sketch y equals 3 sine x. What we did before was y equals sine x. It's the same thing, just that this 3 means that the amplitude is going to be 3. So the values will now range from 3 to -3. So all you need to know is the nature of a sine graph within 360. This is how it looks like. And you sketch it. Simple as that. The amplitude, you know, is 3. Because the height of the wave is 3. The period is 360. Now, pause and see if you can do this yourself. Values ranging from 4 to -4 because there is 4 in front of sine x. So sine graph, you know, it looks like this. Now you sketch. This is what you have. We're going to go in depth more about transforming trig graph. This is just a brief lesson about the nature of sine and cosine graph. Amplitude is 4. As you can see, this height of wave is higher than 3 sine x because 4 is bigger than 3. The same way, if you want to do cos, this is what you have. You just have to make sure it's between 2 and -2. Okay, now this is the main thing I wanted to talk to you about, finding solutions. We are supposed to find solutions of the equation 9 sine x equals 7. What will be the angle that will make this equation equal to 7? And we want to work it out between -360 degrees and 360 degrees. Remember, the angle can stretch as long as you can imagine. The first thing to do is work out for x. So you set up the equation, you work out for x, you divide by 9, and you find the inverse of sine of 7 over 9. And that will give you 51 degrees approximated to 1 decimal place. So we first have one value for x, which is 51 degrees. Now what you need to understand is that 51 is only one solution. But within the stretch of -360 to 360, there are more than one solution. How do you find those solutions? We need to find that using the sine graph. So we have to first sketch our sine graph within -360 and 360. This is how it looks like. In case you're not sure how I got this, just remember, how do you do sine graph from 0 to 360? This is how it looks like. Follow the same pattern and you get it. Now I've got my graph. First is locate 51 degrees. That's 51 degrees. As you can see, that is my 7 over 9. What you see here, 7 over 9. So this is my 51 degrees. Now to find the rest of the solution, let's extend this line. And wherever it cuts the sine graph gives us another solution. So we have 1, 2, 3 additional solutions to work out. To work out the solution, the graph is symmetric. So you see, from this gap, 0 to this point is 51. So it's symmetrical. That means this is also 51. That is also 51. The length of that line is also 51. But you need to be very careful as to when to take away and when to add. So let's start. To find the red one, you see this red line is to the right of -360. So we need to add. Moving to the right is addition. So adding 51 to -360, we have -309 degrees. What about the yellow one? This yellow point is to the left of -180. So we need to take away 51 from -180. -231 degrees. We already know our 51. Then the last point is this. This blue point is to the left of 180. So we need to take away. So the values are now negative 309, negative 231, 51, and 129 degrees. We've managed to work out all the solutions within the given range. Let's look at another example. This time is with cos. 6 cos x equals 3. Work it out within the range negative 360 and 360. Find x first. Inverse of cos s, 3 over 7, which is the same as a half, will give us 60 degrees. We know one solution. So all we need to do is to do our cos graph. This is the nature of cos graph. For 0 to 360, follow the same pattern to the negative zone. Now locate your 60 degrees because it's only one solution. That's my 60, and that's my half. Extend this line. Let's get more solutions. So we have 1, 2, 3 additional solutions to work out. It's symmetrical, so if we know this is 60, we must know this bit is 30. Be careful with this. This is 30, that's 30, that's 30. So you need to be very careful here. This is 60, but this bit is 30. That's the symmetry that we're going to use. 30, 30, 30, and 30. So for the red line, it's to the left of negative 270. So we're going to take away negative 30 from 270. That's what we have, negative 300. For the yellow line, it's to the right. So we're going to add 30 to negative 90. That's negative 60. We know our 60 already. Then the next one is to add 30 to 270. So now our values, x values are negative 300, negative 60, 60, and 300 degrees. So whenever a question like this is given to you, solve it first, sketch the graph, look for the first solution, extend the line, and where the line cuts your graph, bring it down and work it out using the symmetric nature of the values to work it out. Okay, now quickly, how do you determine the coordinates? Like I said before, if you remember your values, you should know the coordinate of A is sine x. So the highest point is 1. This is negative 1. That will be the y coordinate. But what about the x? So the first one is 90 and 1. Second one, B, 270 and negative 1. What about cos graph? 90 and 0. And B will be negative 180 and negative 1. And that brings us to the end of this lesson. Hope you've enjoyed it. Please subscribe and share with your friends. And look out for the next lesson on how to transform trigonometric graphs. That will be a deeper lesson. This is just a brief introduction to sketching the graph. Next lesson is transforming trigonometric graphs. Thank you very much for watching.